Hi everybody, it's Mrs. Mancuso, and today I want to talk about nuclear chemistry. So nuclear chemistry means something is going on with the nucleus. So first of all, these reactions look really different. You actually write about the nucleus in the reaction. And so other things like over here I was doing esterification, like we didn't write about what was in the nucleus of the carbon. This one you actually write the mass, which is the protons and the neutrons, and the atomic number, which is the protons. So uranium can spontaneously be radioactive. And what that means is that it falls apart. Basically, there's not a good ratio between the protons and the neutrons of the elements that are over number 83. Over 82. Lead is pretty stable, but everything over it, the nucleus is very large, and there tends to be this unstableness about the proton versus neutron ratio. So here's uranium, element 92, mass 238. It will spontaneously break and transmutate into another element. So if you want to know what it changes into, you go to table N and you figure out what type of decay it does. So here's uranium 238. It does A, which is alpha. And so that little fish-like symbol, you go over here to O, there's the symbol, and there's how it decays, 4,2-He. So this is a natural transmutation. And a natural transmutation is also called a decay. So its nucleus is changing. Now, I know because of conservation of mass, I can't lose any of this 238. I might lose the tiniest tiny bit, but it doesn't end up in a whole number. So that energy is changed, or that is released as energy. But 238, this and this have to add up to 238. So this must be 234. And then 92, this and this have to add up to 92. So this is a 9D. So I've changed elements. I can go back to my periodic table. Element 90 is TH. So that is the transmutation. I have changed elements. So you can use table N to look up any different radioisotope and figure out how it decays. All right. You could also have artificial transmutation. So an artificial transmutation, because it's not natural, you're going to have two things before the arrow. So I could have my uranium 238, 92, and I could bombard it with a neutron. That means I'm firing a neutron at it. And when I fire a neutron at it, I could get Kr and something and 3 neutrons. So I'm actually splitting this nucleus apart. This is called fission when you split something. So we've got to figure out what these are. So first of all, Kr. You look it up. It is element 36, and let's say it has a mass of 84. Okay, and now I need to figure out what this is. So 238 and 1 is 239. So I need this and this and this to add up to 239. So because I can't use my phone to do this, let me just grab a calculator, make this a little bit faster. Over here I have 3 neutrons, so this is a 3. So I want to take 239 minus 3 minus 84, and I get 152. So the mass of this atom here must be 152. And now at the bottom, this is 92, so I need this, this, and this to also be 92. Well, 3 zeros is still 0. So 92 minus 36 gives me 56. And then I look up what element 56 is. It is barium, Ba. So they sometimes on the Regents chemistry exam have you figure this out. They call this X and you solve for it. So again, make sure that your math all balances. Whatever you start with, you have to end with. If you have 3 of these, then your mass is 3. And then you look up the element to find what it is. So it was artificial transmutation. Artificial because you fired at it. It wasn't a natural decay with only 1 thing before the arrow. It has 2 before the arrow. It's transmutation because the element changed. It was uranium, but now it's krypton and barium. And it's fission because you took a heavy nucleus and you split it. Now here's an example of fusion. To fuse means to come together. So if you bring together light nuclei, so I could have hydrogen and another hydrogen, and I could make helium. That is fusion. I have brought 2 light nuclei together to make a larger nuclei. Thanks for joining me.